Next, units of force. What is the SI unit of force? Newton. What is the CGS unit of force? Dyne. Already you know, isn't it? So let us see the definition of 1 Newton and 1 dyne. Listen. The amount of force required for a body of mass 1 kilogram produces an acceleration of 1 meter second power minus 2. Listen. 1 kilogram object is there. One force acting on the object. What happened? The object start to accelerate, isn't it? The acceleration is equal to 1 meter per second squared, means that force is said to be 1 Newton. So 1 Newton is equal to 1 kilogram meter second power minus 2. Listen. The amount of force required for a body of mass 1 kilogram produces an acceleration 1 meter per second squared, means that is 1 Newton. Okay. So next one, definition of 1 dyne. Okay. So that is also same to 1 Newton. Here 1 kilogram, here 1 gram. Here 1 meter second power minus 2 acceleration. Here 1 centimeter second power minus 2. That's all. Listen. The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter second power minus 2. Okay. So 1 dyne is equal to 1 gram centimeter second power minus 2. So also 1 Newton is known as 10 power 5 Newton. Listen. 1 Newton, 1 gram. 1 gram is equal to 1000 gram. Isn't it? So meter to centimeter, 100 centimeter. 1 meter equal to 100 centimeter. So only we write 1 Newton is equal to 10 power 5 dyne. Next, unit force. Okay. So unit force 1 Newton. Listen. The amount of force required to produce an acceleration of 1 meter second power minus 2 in a body of mass is called unit force. So the difference between 1 Newton and the unit force is nothing. Here the mass specifically given 1 kilogram. Here mass. Okay. Mass is called. Just a mass is called unit force. Okay. Next, gravitational unit of force. So in the SI system of units, gravitational unit of force is kilogram force. That means 1 kilogram force, that is equal to the acceleration due to gravity. G value is 9.8 meters second power minus 2. So that means 1 kilogram into 9.8 meters second power minus 2 is equal to 9.8 Newton. So in the CGS system, its unit is gram force. So 1 gram force is equal to 1 gram into 980 centimeter second power minus 2. That is equal to 980 dyne. Okay. These are all the important definitions. So go through the definition well. Okay. Next one, impulse. Very important term. Listen carefully. A very large force acting for a very short interval of time is called as impulsive force. Okay. So what is that? You think of accident. Listen. A very large force acting for a very short interval of time is called as impulsive force. Okay. So impulsive can be represented by the letter J. So J is equal to product of force and time. Okay. So by Newton's second law, you know what is Newton's second law? Force is directly proportional to rate of change of linear momentum, isn't it? So we write F is equal to change in momentum, that is del P with respect to time. So we want del P means del P force into time. Okay. So del P is equal to force into time. What is del P? Change in momentum. Force into T is known as impulse, isn't it? So what is that? Change in momentum is equal to impulse. So J is equal to del P. So impulse is also equal to the magnitude of change in momentum. Okay. Its unit is, how to write the unit? Force unit is what? Newton. Time second. So Newton seconds. Okay. Otherwise you know you write. Listen. How to write the unit? Kilogram meter second power minus 1. Listen. Force equal to mass into acceleration. So m unit kilogram. Acceleration meter second power minus 2. Okay. So impulse J is equal to force into time. No. So force kilogram meter second power minus 2. Okay, and time t. Okay, so cancel each other, so we get the term kilogram meter second power minus 1. Okay, so change in momentum can be achieved in two ways. They are a large force acting for a short period of time, that means J, large force, small time. Otherwise, a smaller force acting for a longer period of time. Very smaller force, time larger. Okay. So in your book, they given two examples. I give one more example for you. Listen. Airbags in cars designed with impulse. When a driver gets into an accident, their momentum carries them forward into the steering wheel, isn't it? By putting airbag in the car, a smaller force is exerted over a longer period of time to change the momentum of the driver to stop. Okay, this is impulse. Okay, what is impulse? A large force acting for a very short interval of time is called as impulse. Okay, next one, Newton's third law of motion. Okay, next one, Newton's third law of motion. So everybody knows the law. Listen, for every action there is an equal and opposite reaction. They always act on two different bodies. That is important point. For every action there is an equal and opposite reaction. They always act on two different bodies. Listen, if your body, two bodies A, B. If your body A applies a force Fa on your body B, so the B reacts with the force Fb on the body A. So the force Fa in equal to the magnitude but opposite in direction. Okay, so only we write Fb is equal to minus Fa. Okay, so in your book also they given three examples. I give more examples for you. Listen, when you walk, you push the stick, that is you apply a force on the stick and the reaction force move you forward, isn't it? So while rowing a boat, when you want to move forward on a boat, you paddle by pushing the water backwards, causing you to move forward. Okay, so what is Newton's third law? For every action there is an equal and opposite reaction. They always act on two different bodies. Okay, so today over pa, that's all students. So today's homework, you don't forget to study. State the principle of moment. In your book, page number 14, they given sixth question. State the principle of moment. That is very important 4-mark question. So study and write the question. Next, 8th Roman letter question answer. That is answer in detail. Second question, that is state Newton's laws of motion and they deduce the equation for a force using Newton's second law of motion. Okay, so study the question answer thoroughly. Thank you, students.